Which of the following statements are true about the graph of the polynomial function f of x is equal to x cubed plus bx squared plus cx plus d? A. It intersects the vertical axis at one and only one point. Well, first of all, let's recall a characteristic that all points on the vertical axis have in common. The vertical axis is the y-axis, and on the y-axis we have points like 0, -3, 0, -2, 0, -1, 0, 0, 0, 1. The key characteristic that all those points have in common is that the x-coordinate is 0. So if we want to find where the graph intersects the vertical axis, all we need to do is substitute 0 for x and then evaluate. We get 0 cubed plus b times 0 squared plus c times 0 plus d, which evaluates to d. Since f of 0 is equal to d, that means that the point 0d is on the graph of this polynomial function. So A is true. The function intersects the vertical axis at one and only one point, at the point 0d. Let's move down to D. The vertical intercept is positive. Well, we've already determined that the vertical intercept is 0d, and it is possible that the vertical intercept is positive. However, the value of d is not given to us. Therefore, it might be negative, it might be 0, it might be positive. So it is possible that the vertical intercept is positive, but it could be 0. It could be negative. Therefore, the answer to part D is false. Let's go back to part B. It intersects the x-axis and at most 3 points. Well, let's suppose this was a false statement. Suppose the function intersected the x-axis in more than 3 points. Let's say 4 points. Let's suppose the function intersected the x-axis at C1, C2, C3, and C4. Then what that means is that x minus C1 would be a factor of the function, and x minus C2 would be a factor of the function, and x minus C3 would be a factor of the function, and so on. Therefore, our function could be written as f of x is equal to the factor x minus c1 times the factor x minus c2 times the factor x minus c3 times the factor x minus c4 times possibly another polynomial factor. Well, what happens when we multiply all these factors together? Well, multiplying the first terms, we get x times x times x times x, and that's equal to x to the fourth. But let's look at the degree of our polynomial function. The degree is 3. Since the degree is 3, that means that the function can only intersect the x-axis at most 3 points. So B is true. To answer part B, we could have just recalled an important connection between the degree, the number of x-intercepts, and the number of turning points of a polynomial function. The graph of a polynomial function of degree n with n greater than or equal to 1 has at most n x-intercepts and at most n minus 1 turning points. In this case, our polynomial function has degree 3. Therefore, the polynomial function can have at most 3 x-intercepts and at most 3 minus 1, or 2 turning points. Therefore, we can also answer part F. Since our polynomial has degree 3, that means that the graph of the polynomial function has at most 2 turning points, and that means that F is true as well. Part C. It intersects the x-axis at least once. To answer this part, let's think about the end behavior of our polynomial function. The end behavior of a polynomial function is exactly the same as the end behavior of the leading term. In this case, our leading term is x cubed. So let's recall what the graph of y equals x cubed looks like. We see that the graph of f of x equals x cubed falls to the left and rises to the right. Therefore, the graph of our polynomial function will do exactly the same thing. And since it falls to the left and rises to the right and is continuous in between, it must cross the x-axis at least once. It might cross more than once, but it needs to cross at least once. So the answer to part C is true. Finally, for part E, we have as x goes to infinity, f of x goes to infinity. Well, again, to answer this question, we simply need to look at the behavior of the leading term. What does the graph of y equals x cubed look like? It's going to have the same end behavior as the graph of y equals f of x. So we look at our graph. What happens as x goes to infinity? Well, as x goes to infinity, the function is increasing without boundary. F of x is going to infinity. So this is a true statement.